Welcome back everybody to Geology 101. So far we've been going through the rock cycle. We started with igneous rocks, then sedimentary, and now finally we finish it out with metamorphic rocks. Let's get started. Our first section is going to cover metamorphism. Going back to our rock cycle diagram, we've covered igneous rocks, we've covered sedimentary rocks, we've talked about all the different processes involved, and now we talk about how these two become metamorphic rocks. What is this process of metamorphism? So metamorphism simply is rock cooking. You take a rock, you expose it to high temperature and high pressure, and you cook it. And just like with regular cooking, you're not melting whatever's involved necessarily, right? You put a cake into the oven, you change it chemically, but you haven't melted it. That's not what's happening. Metamorphism is just like metamorphosis that you might have learned about in school. We have meta, which means change, morph, which means form. Metamorphism is a change in form. And now for rocks, the change can be in things like mineralogy, chemical composition, texture, structure, or all of the above. And typically this is going to take place deeper in the ground than everything we talked about for sedimentary rocks. Now, before any of the metamorphism has taken place, we have our original rock, something called the protolith. Proto is first, lith is rock. This is going to be our parent rock, which later becomes metamorphosed and becomes a metamorphic rock. Now, broadly speaking, we can have rock that is a little bit cooked, right? Rare, medium, or we can have rock that is cooked thoroughly, medium well, all the way up to well done. So we call this low grade if it's been cooked a little bit. Temperatures up to about 400 C. 400 C is about 750 degrees Fahrenheit. Pressures up to 400 MPa, we'll talk about in a little bit. Everything from 5 to about 15 kilometers below the Earth's surface. And for reference, going all the way through the crust to the mantle, that puts you at about 35 kilometers when you're on land. So we're about a third of the way there for low-grade metamorphism. Now the pressure's up to 400 megapascals or million pascals. What does this actually mean? Well, I have a chart for here for reference. Tire pressure is about 0.2 megapascals. A human bite is a little more than 1 megapascal. Car wash is about 5 times that much. A bullet is about 20 megapascals. And then finally, Mariana Trench, which is the deepest point in the ocean, the deepest point in the deepest ocean on Earth, is about 110 megapascals. So by comparison, 110 megapascals would put you at the low end of low-grade metamorphism. To be high-grade metamorphism, it's got to be temperatures above 400 C, pressures above 400 megapascals, everything from 15 to about 35 kilometers below the Earth's surface. But what does this actually look like? Well, you imagine we took a slice of the Earth like this. We have our crust on top, mantle on bottom. And we'll start out up here towards the surface, maybe the first 5 kilometers, not very deep at all. Here we would be in the zone where sedimentary rocks are created, what is called the region of diagenesis. So we've made sedimentary rocks up here. You imagine as we go deeper and deeper, we start to move this way on the diagram, first passing through the region of low-grade metamorphism, and then through the region of high-grade metamorphism. So everything in about here on our picture is going to be the zone where metamorphic rocks are created, corresponding to about this range on our temperature-pressure diagram. Finally, if we get too deep, we get too much heat, we actually start to melt the rocks, and we haven't made metamorphic rocks at all. Too much heat has been added. We've gotten into this zone where we've made igneous rocks. So now we know something about metamorphism, what it is, and maybe where it occurs, but, well, in geology, we sort of work backwards. We take the rocks first, and then we work backwards to figure out how they formed. So what do these metamorphic rocks actually look like?